Welcome to Spring LIB.
So in this problem, we are given three compounds. One is acetone, which is a non-electrolyte, then hypochlorous acid, which is an weak electrolyte, and ammonium chloride, which is strong electrolyte. Now, first question is, what are the solute particles in aqueous solution for each compound? So, first one here is acetone, which has a formula of CH3 COCH3. And since it's a non-electrolyte, that means that in an aqueous solution, it will remain as neutral molecule and not ionized into its positive or and negative ions. So in aqueous solution of acetone, the solute present will be the acetone itself. Then in case of HClO or hypochlorous acid, which is a weak electrolyte, that means it will remain mostly in its neutral molecular form, but there will be some of the HClO being being dissociated into its ions as H plus and ClO minus. So in the aqueous solution of hypochlorous acid, there will be three solutes. One is hypochlorous acid, then H plus and ClO minus. And then in case of ammonium chloride, which is a strong electrolyte, that means it will be completely dissociated into its ions NH4 plus and Cl minus. That means in an aqueous solution of NH4Cl or ammonium chloride, the solutes present will be NH4 plus and Cl minus. Now, in the second part of the questions, we have to answer for 0.1 mole of each compound, which one will contain zero point 0.2 mole of solute particles. So, as we know that in an aqueous solution, the strong electrolyte will be dissociated into its ions, and each ion will contain the same number of moles as the original compound. So in that case, in here we have um, NH4Cl, which is the only strong electrolyte. That means NH4Cl will produce NH4 plus and Cl minus. And since we have zero point 0.1 mole NH4Cl here, that means being completely dissociated, it will produce zero point 0.1 mole NH4 plus and zero point 0.1 mole Cl minus. That means in the solution we will have in total zero point 0.1 plus zero point 0.1, in total 0.2 mole solute. Then in case of the non-electrolyte acetone, as there is no ion present, that means the only solute present is acetone, and since it's zero point 0.1 molar, that means in case of acetone, the number of moles of solute will be zero point 0.1 mole. And in case of the HCl or hypochlorous acid, it will be slightly dissociated into H plus and um, ClO minus. And basically, its aqueous solution will be composed of this HClO, which is zero point 0.1 mole, and it will be slightly dissociated into H plus and ClO minus, and which will be, and the total concentration of these two will be less than zero point 0.1 mole. That means um, there will be 1 mole HClO and less than 1 mole of H plus and ClO minus, since it is not completely ionized or dissociated into its ions. That means the total solute moles for HClO will be somewhere in between zero point 0.1 to zero point 0.2 mole.